Hello, chemistry. Mr. McKee here, and we're going to talk about the final two types of chemical reactions that you guys need to learn. Those will be single displacement and double displacement reactions. So eventually we're going to learn how to predict if these reactions will happen and how they happen, but today we're just focusing on recognizing the difference between the two. And it's pretty straightforward. Um, First thing to note is that these are going to typically be ionic reactions where we're dealing with a bunch of different ions kind of shuffling around from one side to the other. So it's going to be good if you can review the difference between cations and anions and polyatomic ions. We'll talk about some of that as we go through the examples here. And I'm going to use an analogy to understand what's going on here. And the analogy is we are at a dance, like a high school dance, prom or winter formal, something like that. So let's look at single displacement reactions first up here. In this scenario, we have a single individual represented by the variable A here showing up at the dance. And then we have a couple showing up at the dance. And if a single displacement reaction occurs, basically the couples are switching dance partners. So keep in mind that A and B are always going to be cations or metals, and C is going to be an anion over here, a nonmetal or a polyatomic anion. Okay, so again, basically what we have is A pairing up with C on the other side, and B gets left out in the cold here. So we have the switching of dance partners. Another way to look at it is that A steals B's dance partner, okay? The specific example is we have both copper and silver down here, and they would both like to dance with the nitrate, but we see here from the reaction that copper is the one that wins out in this contest to dance with the nitrate. So it pairs up with it, and silver gets left out in the cold over here. We're going to learn why copper is preferred by the nitrate to silver, but we don't need to understand that right now quite yet. We're just looking to recognize the different forms of equations here. Okay, the other type of reaction we're talking about today is the double displacement. And this is characterized by, we have two couples showing up at the dance together. We have A with B and C with D. And basically these couples both size each other up, and they decide that they would both like to switch dance partners. So specifically down here in this example, we have calcium chloride and sodium phosphate. Again, it's worth identifying the cations and anions here. Remember that the cation is always listed first in the compound's formula. And we're going to have a switching of dance partners. And the important thing to note is you're always going to have a cation with an anion. So over here on the other side, sodium is now going to be with the other anion, chlorine, and calcium is going to be with the other anion, phosphate. So again, we have a switching of dance partners. But it's really obvious the difference here because we have nothing but couples, to use my analogy, in the case of a double displacement reaction. But it's pretty easy to identify we have some single individuals when we have these single displacement reactions. But in both cases, we have a switching of dance partners. So continue to practice your balancing as you go through these practice problems. Remember that practice makes perfect with that. And as always, reach out if you have any questions. Have a great day.